When someone fires a projectile, its initial velocity can be represented by a vector where the magnitude is the overall speed and the angle is the direction of the projectile. After its launch, a projectile's motion can be divided into vertical and horizontal. So when we throw a ball horizontally in the air, then it tests a parabola-like loop and then falls down. This is an example of projectile motion. This happens with any object that we throw at an angle to the ground, and the main force acting on the object during the travel is the gravitational force. Projectile motion is a form of motion where an object moves in a parabolic path. This equation defines the maximum height of a projectile above its launch position, and it depends only on the vertical component of the initial velocity. The equation for the distance traveled by a projectile being affected by gravity is sine 2 angle multiplied by the square of initial velocity over acceleration due to gravity. Assuming that v squared over acceleration due to gravity is constant, the greatest distance will be when sine 2 angle is at its maximum, which is when 2 angle is equal to 90 degrees. The horizontal velocity of a projectile is constant. There is a vertical acceleration caused by gravity. Its value is 9.8 meter per square second down. The vertical velocity of a projectile changes by 9.8 meter per second each second. The horizontal motion of a projectile is independent of its vertical motion. The horizontal and vertical components of two-dimensional motion are independent of each other, which means any motion in the horizontal direction does not affect motion in the vertical direction and vice versa. It is also true of more complicated motion involving movement in two directions at once. For example, let's compare the motions of two balls. One ball falls from rest, the other has an initial horizontal velocity. Each subsequent position is an equal time interval. Arrows represent horizontal and vertical velocities at each position. The ball on the right has an initial horizontal velocity. Despite the difference in horizontal velocities, the vertical velocities and positions are identical for both balls. This shows that the vertical and horizontal motions are independent. Projectiles travel with a parabolic trajectory due to the fact that the downward force of gravity accelerates them downward from their otherwise straight-line, gravity-free trajectory. Let us all remember that when someone fires a projectile, its initial velocity can be represented by a vector where the magnitude is the overall speed and the angle is the direction of the projectile.